Lesson number 12 is on potential energy. We've gone into depth with kinetic energy, how to calculate kinetic energy, and how to use that formula to find either mass or speed. Now we're going to look more in depth at potential energy. Now, like we looked at before, there's various types of potential energy. Elastic potential energy, where if you stretch an elastic band and let it go, it has the potential to snap back or to move in a certain direction. The work is transferred to something else. Like a spring, so if you push or press on a spring, it has the energy to press back. The one type of energy, though, that we are going to be calculating has to do with gravitational potential energy, so the potential for an object to fall. In this case, either the ball or the bear. The formula that we're going to use is this one right here. It's very straightforward. Energy, so the EP, the E stands for the amount of energy. Again, the units that we're going to use to represent energy are joules. The P, that's right beside it, just tells us that we're looking at potential energy instead of kinetic energy, equals mgh. Now M, just like with the kinetic energy formula, is the mass. Mass is represented by kilograms. G is the acceleration of gravity, so how fast the object will accelerate as it's dropped. Okay, on Earth, that number that we're going to use is 9.81, and that's a constant. That's something that is always the same, so anytime we're doing a calculation and it's on Earth, we assume that that number will always be 9.81, and the units are in meters per second squared. The H represents the height above the ground, and we're going to again use meters, just like we did before. So E equals mgh. In lessons previously, or in years previously, you should know the difference between mass and weight. The mass is the amount of matter, or the amount of stuff in an object, and the weight is how much gravity is pulling down on the mass. So if we look at our picture here, the Space Explorer weighs more on Earth because gravity is pulling down more on Earth than the same space traveler is being pulled down on the Moon because the gravitational pull is different. So if we look at the formula down here, and we won't need to use this, this is just for your understanding. Fg stands for your gravitational force, that's the weight in newtons, is going to be the same as your mass times your gravity. How does something get potential energy? The transfer of mechanical energy from one object to another. Remember, just like before, work equals force times distance. Work is measured in joules. Energy is measured in joules, so these two can be used interchangeably. So in your question, if you're given your mass and your height, and it asks for how much work can be done, you're still just using this formula to calculate your work or your energy. Now, we're going to try out a couple of examples. If you have any questions, please ask. There will be some questions at the end that I'd like you to try out for tomorrow, and we'll go over them tomorrow in class. This first question, again, we need to recognize what we have. Man sits on a cliff that is 350 meters above the ground. That's our height. If the man has a mass of 85 kilograms, okay, that's our mass, what's the potential energy? So write down what we have. Energy is the thing we do not have. That's what we're looking for. The mass is 85.0 kilograms, and that's already in kilograms, so we don't have to convert it. The man is on Earth, or we assume he is. So the G, the gravitational pull or gravitational acceleration, is 9.81, and the height is 350 meters, which again, also in the correct unit, so we don't have to convert it. Okay, we write down our formula for our first mark. We substitute our numbers in. 85.0 times 9.81 times 350 equals 291,847.5. We have 3 significant digits for our mass. We're given 3 significant digits for our height. We do not count our constant because that's a number that we weren't given in our question. So our answer here is going to have 3 significant digits. So after we have reduced it, the 2 answers that are totally acceptable, the first one just in changing to scientific notation, okay, 2.92 times 10 to the 5th joules, perfectly fine. or 292 kilojoules. Both of these answers are acceptable. They both have 3 significant digits and they both have correct units. For question number 2, we have to see what we have. So we have a mass that we're given, already in correct units. We are also given the energy. Okay, so it's asking what the height is. So that means we need to rearrange our equation. First, we're going to write down what we've got. And we have 288 joules of energy, 1.20 kilograms for our mass. We assume we're on Earth, so our gravitational acceleration is 9.81, and we don't know our height. So again, you can either have just the regular formula up here and solve that way, or you can rearrange the equation and then solve after it's been rearranged. Okay, so we're solving for our height. So we need to move our mass and our gravity to the other side of our equation. Right now, those two are being multiplied to h. The opposite of multiplying is dividing. So we're going to divide by m and g. What we do to one side, we must do to the other. So our formula that we end up with is E over mg, or E divided by mass and divided by gravity. So if you are looking for either the mass or the gravitational pull, the formula is the exact same. If you're looking for the mass or the gravity, you would rearrange this the exact same way, all in one step. Now we're going to substitute in our numbers. So our height equals 288 divided by 1.20 and also 9.81. Make sure that you're careful to multiply the bottom first together, then take 288 divided by that answer, or you can take 288 divided by 120 and then divided by 9.81 as well, so that you end up with the correct answer. In the end, you should end up with 24.4648. And in our question, we have 3 significant digits for our energy. We have 3 significant digits for our mass. We do not count the constant that we are given. That's not a measurement that was given in the question. So our answer must have 3 significant digits as well. The next number after the ones that are significant is 5 or higher. It's a 6. So we are going to round our 4 up to a 5. So our final answer here, 24.5, and we'll include our units in meters.